Okay, now let us focus on this question here. It's a proof in projectiles. So it says, a particle is projected from point O with initial velocity, speed u pass through a point which is at horizontal distance A from O and distance B vertical from O. Show that there are two possible angles of projection. If these angles are alpha and beta, prove that that is true. So we start with our sketch. Now this is going to be my sketch here. I have this now, this is going to be my horizontal ground there. They are telling me that they are projecting a particle from this point, then it will come like this, then after, of course, it will go and then it will fall there somewhere. Now they are telling me that it's given an the initial velocity here. They are telling me this is u meters per second. So now this particle is going to be passing through a point P. Then we call this point P. Maybe if they don't specify it, then we call it Py. And now this point, they're telling us at this point from here up to here, this distance here is going to be B. Then they're telling us that F meters from, so meaning from there up there, they are 8 meters. Of course, at this point, that the x is going to be, which implies from there is that our x. At this point, our x is going to be A, then our y is going to be B from here. At this point, Px. That point Pxy. Okay, now you see, it's going to be having, at this point, it will be having a certain velocity, which we are going to say this velocity is going to be V. Now, if we this one is going to be R1Vx, and this one is going to be R1Vy. If we resolve that velocity there, now it implies that now if I want to get now the horizontal direction from here, if I want to get now the vertical motion, and vertical motion using my V equal to U plus 80. Now my V y will be Uy minus Vt. Hope you remember that. But we said, remember, our U, our Uy, we said it's going to be U sine theta, and our U, x, we said it's going to be U cos theta from the introduction part. So, if this is our angle, let us call this angle here alpha. Let us call this angle, let me call it alpha, the angle of projection. So now, meaning that this one is also going to be cos alpha, then this one is also going to be sine alpha, cos alpha. So now, this will be my Vy, will be there, U sine theta minus Vt. What about the distance? Our distance is given by Ut minus, okay, plus a half 80 squared. So my s in y will be Uy t minus a half Vt squared. Why are we having negative? Because this one is acting against gravity. So our sy, the horizontal distance, which we can see from here, is going to be the y we are looking for. So our y here is going to be our Uy, which is U sine alpha minus a half Vt squared. And when it comes to horizontal motion, you can see that from our V, x will be Ux minus, okay, plus At. Horizontally, that one is always 0. Acceleration is 0. So we have our Vx equaling to U cos alpha. Then our distance, from our distance, our Sx will be equal to Uxt. Of course, the other one is going to be plus a half into 0t. So our Sx here is going to be Ux, which is U cos alpha t. But what is our Sx? Sx is going to be our horizontal distance alpha t. Now this was the basic recap, and I was just getting the recap. Now from here, if I make t the subject, from here so my t will be x over u cos alpha. I call this equation 1. So if I come and I substitute from y equaling to u sine alpha minus a half t squared. If I substitute this into this, I'll be having now y equaling to u. Sorry, here I missed the t. Yeah, here I also missed the t. Then sine alpha into where there is t, we put this x over u cos alpha, then minus b into x over u cos alpha, the whole square. So from there, if you simplify, you see this c will go with that one. This one is going to give us y equaling to x sine alpha over cos alpha, then plus minus half x squared over u squared. This is going to be all over cos squared alpha. But you note that 1 over cos squared alpha is equal to sec squared alpha when you take it up there. So this will be y equal to x. This is going to be our tan alpha, then minus a half u squared, then x squared sec squared alpha. So now, but you know that sec squared alpha is the same as 1 plus tan squared alpha. So our y here is going to be x tan alpha minus x squared into 1 plus tan squared alpha, the whole over 2u squared. So allow me to multiply through, sorry, we are missing our b. This b here, shouldn't miss that b. So if I multiply through by 2, if I multiply through by 2u squared, so 2u y, then equaling to 2u squared x tan alpha, then that will be x squared b into 1 plus tan squared alpha. I want to show that I want to form a quadratic equation, because for it to be having 2 angles, then I should be having a quadratic equation there. So if I divide it through by, okay, if I take this side, I'll be having now x squared b 1 plus tan squared alpha. When I take everything this side, then plus here I'll be having, it's going to be a minus if I take it to the other side. So this one will turn into a minus. So I'll be having now minus 2u squared x tan alpha. Then this side we shall be having plus 2u squared y, the whole equaling 0. So can you form a quadratic from there? You see, we shall be having, if you open brackets, we shall be having there. Okay, let me open brackets here. This, okay, let me do it here. I'll be having now x squared d, then plus x squared d tan squared alpha, then minus 2u squared x tan alpha, then plus 2u squared y equaling 0. So, if we divide it through by this, you see I'll be having tan squared alpha, then minus, I'm dividing through this here, 2u squared x, tan alpha, the whole over x squared y, then plus 2u squared y over x squared y, then plus this one here, okay, x squared y over x squared y equaling 0. We have brought this here. Okay, from there what do I have? I have tan squared alpha minus what? You see what x is going to go? So I'll be having 2u squared x, y times alpha, then plus, what are we having here? We are having, where is our b by now? Is that b or is it b? Here I'm going to throw by b. This b, that b, and then that b. So be careful there. Okay, so this is going to be xb, okay, tan alpha, then plus a 1 there, okay, plus 2u squared b, y over x squared b, then plus 1 equaling to 0. And then you see this is a quadratic equation. Hence, quadratic equation, quadratic equation, there are two possible angles of projection. Quadratic equation that will produce two possible angles. Then part B, so this was our part A. Then part B, I think that's that if the angles are alpha and beta, okay. So they are telling us that if the angles are alpha and beta, it implies that now, if we compare the general quadratic equation, ax squared plus bx plus c equal to 0, it implies that now, remember, the two roots, the two angles are alpha and beta, implying that now our roots are tan alpha and tan beta. So meaning, if we get the sum, our sum is always negative b over a. So implying that if you compare there, it's that now my tan alpha plus tan beta will be negative of this, which will give us negative 2u squared over xb, which will be 2u squared over xb. Then our product, remember, be given c over a, implies that now my tan alpha, tan beta will be equal to c over b. This will be the thing, which will be 1 plus 2u squared y over x squared d. So now, this is that I have a sum and I have a product. What comes into your mind? When you look at what if they are summing them. Now I know tan alpha plus beta will be equal to tan alpha plus tan beta, the whole over 1 minus tan alpha tan beta. So substituting in there, this will give us, okay, if I'm substituting there, that sum is going to give me 2u squared over xb. This is the sum. Then I'm going to be dividing it with 1 minus. Now the product, our product is here, which is, okay, which will be 1 plus 2u squared y over x squared b. Okay, so in open brackets, this is going to vanish, so we shall be having 2u squared over xb divided by, now a negative is negative, 2u squared y over x squared b. Now, from there I think you see, this one is going to vanish with that. Then this b will also vanish. Then 1x is also going to vanish with this. So it's that we shall be having 1 divided by negative y over x. We can start now my tan alpha plus beta. The reciprocal of that will be now negative now x over y. Now what is my x? There our x we said is that. And so my tan alpha plus beta is going to be negative into A over B, and the proof is out. Because here, this displacement from here up to here is x, which is from this point. From if this is O, from here up to here is going to be x, which is A. Then from here up to here is going to be y, which is the distance below us there, which is the proof there. But now, the other thing is, by those angles, the alpha and beta, they are always complementary angles. I mean, they are complement. Meaning, when you sum this and this, you get 90 degrees. There is a proof about that also, but that's not the case for now. So that's how you handle that. I wish you well.